In this video, I'm going to show you how to migrate a configuration from a Hirschmann RS40, this one, which is a classic software-based device, to a Hirschmann BRS50, this one, which is a HiOS-based device. I will say right at the beginning that the tasks in this tutorial are simple for people who are experienced with configuring switches. If you are unfamiliar with switch configuration, you can still follow what I'm doing step by step, but be prepared for a learning curve. On the way through, I'll show you some tips and tricks to make the migration tasks easier. At the end of this tutorial, you will have a good grounding in the theory and practice of configuration conversion. Before we get started, let me explain some limitations. The classic products have been in production since 2007 and, as you would expect, are using older technology. The HiOS devices feature state-of-the-art hardware combined with the latest software functions. HiOS devices fit perfectly as drop-in replacements for classic devices. But not every function can be directly translated from one platform to another by the configuration conversion application. There are 4 reasons. Firstly, a function in classic software may no longer exist in HiOS. In this case, the function will have been superseded by a more contemporary function. Secondly, the function does still exist, but the command syntax has significantly changed. For example, the function has been expanded to include other options. Thirdly, commands might need to be entered in the configuration file in a different order. Fourthly, the function involves usernames or passwords. We don't want account information to be visible in plain text, so we've either scrambled it or omitted it entirely from the configuration file. But don't be concerned about these exceptions. There are very few of them, and during this tutorial, I'll cover how to manually update the output from the configuration conversion application. For the practical work in this tutorial, I'm going to be using a tool called HiView. This is a tool developed by Hirschmann specifically for the commissioning of Hirschmann Classic and HiOS switches. It has several advantages over other tools. It can discover switches which are in factory default and displays a meaningful summary for each discovered device. It opens the graphical user interface of the classic switches, and it has an integrated secure shell client. HiView is a free-of-charge tool, and you can download it from the Belden website or from the Hirschmann Technical Support Desk. Details are in the description below. In order to demonstrate the migration of configuration from the RS40 to the BRS50, the RS40 must, of course, have a configuration which is not factory default. So, in my RS40, I've configured some parameters which reflect a typical configuration of your switches. I've also deliberately configured some parameters which cannot be directly converted, so you can learn how to deal with these parameters. Let's take a look at what's configured on the RS40. I'm using HiView to discover the RS40. There it is. You can see the IP information, the product name, and the software version, which in this case is Layer 2 Enhanced. The default admin password for the RS40 is private 7 letters. As I've typed 10 characters, you know that the admin password has been changed. The device name is HS-B1-C3 or Hirschmann Switch Building 1 Cabinet 3. The location and contact have also been changed. Port 8 has been disabled. The auto-negotiation has been disabled on port 9, and the port is hard configured as 100 megabits per second half duplex. I mentioned earlier that the admin password has been changed. It's not visible in this screen, but I've synchronized the password with the SNMP community, so it will be visible there. Now you see that the admin password is my password. Not very strong, but good enough for a demo. The aging time has been modified to 600 seconds. There's an additional VLAN with the ID 1503. The egress rules include uplink ports and end device ports. And here are the ingress rules. MRP is enabled, and this switch is the ring manager. Spanning tree has been disabled. The switch is configured to send critical messages to a syslog server. The alarm for power supply 2 has been disabled because a second power supply is not being used. The switch is sending SNMP traps. The Ethernet IP management protocol is enabled. Now you've seen the parameters which are not in their factory default values. Let's remind ourselves what software is running. Layer 2 Enhanced. Enhanced software only offers a binary configuration file. There is no text configuration file. My last point about the lack of a text configuration file is important. It's not possible to migrate a binary file because it's not readable. So I must have the switch configuration as a text file. Now I'll show you how to do this using the command line. The resultant file will contain parameters which have been changed from their factory default values. In other words, the parameters we just looked at in the graphical user interface. This exercise is interesting even if all you want is a list of changed parameters for your network documentation. I will open the command line using HiView. The enable command puts me into the privileged mode. Show running config lists only the changes from factory default which are in the currently running configuration. Highlight the output of the command. Then use Ctrl+C to copy it. Paste it into a text document and save it. Now let's take a closer look. the VLANs, the IP information, contact information. In the ports listing, you see port 8 is closed. Port 9 is hard-coded for 100 megabits per second half duplex. There is the syslog and SNMP trap information. Power supply 2 status is ignored. Ethernet IP management is enabled. MRP is enabled with Ring Manager. Of course, the various passwords are not readable. Spanning tree is off, and the aging timer is 600 seconds. So, to reiterate, I now have the switch configuration in a text format. More specifically, the text in the file consists of the commands used to configure the parameters. In other words, if you were going to configure the switch manually, these are the commands you would type into the switch. For the sake of completeness, I will now show you how to get a text configuration file if your devices are running Layer 2 professional software. For this demo, I have another RS40 which is configured exactly the same as the previous one. Note the L2P software version. Now you see an option which was not available in the L2E version. Save to PC as script. So let's do it. We are finished with the GUI. Now I'll compare the two files. The one from the L2P device on the left and the one from the L2E device on the right. The two files contain the same information, which is what I would expect. Good. Now we have the configuration of the RS40 in a text file which contains the differences between the running configuration and the default configuration. The next step is to convert the configuration file from classic format to HiOS format. I'll do this using an online tool located at convert.hirschmann.com. One very important thing, your switch configuration never leaves your PC. It's not uploaded to a server. The conversion is done in your browser. Here is the conversion tool. It's worth reading the description to get an understanding of the process and the target audience of the tool. You will need to view and accept the beta terms and conditions. Drop the classic configuration file into the left pane. Then click the Convert button. In the right pane, you immediately see the equivalent configuration file in HiOS format. Download it. Now I'll rename the file so I can keep track of which file belongs to which device. It's important to keep the .cli file extension. We are making progress. Now let's take a closer look at the new configuration file. I'm using Notepad++ to remind myself that I'm editing the HiOS configuration file. At the beginning of the file, you see the parameters which could not be converted from the classic configuration file. Below that, you see the parameters which have been converted. I think you recognize them now. So let's go back to the parameters which could not be converted. I have a choice. I can ignore the failed conversions for now and fix them later using the GUI on the new device, or I can fix them now in the config file and reduce the effort later. I prefer the second option. The first entry is the IP address of the syslog server. In HiOS, there are many enhancements to the way syslog is implemented. For example, it's possible to encrypt the syslog messages. As a result, the command to configure syslog in HiOS is quite different to the command used in Classic. What you see here is that the command to enable syslog has been converted, but the IP address of the server has not. So I need to know what is the correct syntax of the command. The easiest way to do this is to look in the manual. The manuals are available online at doc.hirschmann.com. I can just search for syslog, but there are quite a few entries to work through. There is an alternative technique. The manual contains two sections. The first section is for the graphical user interface, and the second is for the command line interface. In this case, I need the second section. I can find the syslog chapter by looking through the index. Here I see the command to add a new IP address to the list of syslog servers. I copy it. Now I add it to the configuration file. The second unsuccessful conversion is a command for a function which is obsolete in HiOS. So the equivalent command does not exist. The remaining entries concern the passwords. For security reasons, usernames and passwords are not converted. So I will make a manual entry. By default, the BRS50 has an administrator user called admin. So all I need to do is configure the password for the admin user. Now my HiOS config file is ready to be uploaded to my BRS50. There are several ways to get the configuration into the BRS. The traditional way is to upload the configuration file into the BRS using a TFTP server. But I would like to show you a couple of alternatives which you may find more convenient. Both techniques involve using an auto configuration adapter, or ACA, which is removable memory. This is the ACA I will use. The first technique works well if you have one ACA per switch, which in any case is a very good idea for faulty device replacement. Step 1 is to prepare the ACA. The ACA is the F drive on my PC. I copy the config file onto the ACA. Next, I need to create a text file with a very specific content. The only line will be script equals and the name of the config file. I'll mention again that the file extension of the config file must be .cli. Then I save the text file onto the ACA with the file name startup.txt. All that is needed on the ACA are these two files. In the next section, I'll boot the BRS with the ACA inserted, and this will cause the configuration to be transferred. It's important to understand that this is the only configuration which will be loaded. Any configuration which is already stored on the device will not be loaded. I would like to show you that the BRS50 is in factory default, so I'll discover it using HiView. As you can see, the switch is a BRS50. The IP address information is all zeros. The system name is default, and the password box is checked, which indicates there has never been a login to the switch. Now let's watch the actual boot process. Okay, the BRS is powered. Now the ACA is powered. The switch is checking if the ACA is present, and it has recognized the ACA. The ACA LED on the switch flashes 3 times per second to show that the switch is reading from or writing to the ACA. So now the switch is reading the config file from the ACA. Remember that the config file includes the command to ignore the status of the second power supply. The switch has loaded the config file, and the status LED is green for OK, even though only the first power supply is connected. So we can be confident that the configuration has loaded. The port link state is up. The switch is writing its configuration back to the ACA. That looks good. But just to prove that the configuration was transferred correctly, I'll log into the GUI and check some of the parameters. This is the HiView window from before the BRS upgrade. I'll reload it to check the difference. There is the BRS50 again. This time the IP address information is correct, the system name has changed, and the password box is no longer checked. Now I'll log into the GUI. The username is still admin. You remember I changed the admin password to my password. Let's see if it worked. The first test is passed. The system information is correct. Port 8 is disabled. The aging time is 600 seconds. The new VLAN is present with the correct uplink and end device ports. MRP is active together with the Ring Manager function. Spanning tree is disabled. Syslog is enabled with the correct server IP address. The alarm for power supply 2 is disabled. The trap destination is configured. Ethernet IP management is enabled. So we can say with certainty that the configuration transfer was successful. As I mentioned before, this technique works well if you have one ACA per device. But maybe you only want to use a single ACA which contains the configuration files for multiple devices. This technique requires you to use the CLI of the switch. You can do this via the serial port, in which case you do not need to configure an IP address. Or you can do it via SSH, which is what I will do now. In contrast with the previous method of booting with the ACA, in this technique the configuration which is stored on the switch will be loaded first, and then the configuration from the ACA will be loaded on top. On my ACA, I've loaded 4 different configuration files for the switches in cabinets 3 to 6. First, I'll discover the BRS50, which is back in factory default and therefore has no stored configuration. As I want to use SSH, I need to give the switch an IP address. No gateway, no system name. There is no point saving the configuration because I'm about to upload another configuration. As this is the first login, I have to change the password, so I will do it in advance. Now I can log into the CLI. I'll copy the configuration file from the external ACA to the running config. Copy, script, envm, then I press return. Now I can see the 4 files which are stored on the ACA. The configuration is being applied to the switch. Lastly, I'll save the configuration to the permanent memory. Finished. Let's double check. The gateway and system name are set, so the configuration was successful. That brings us to the end of the tutorial. You now have the knowledge you need to transfer the configuration file from a classic to a HiOS device, which means it's time to get some practical experience. Even if you do not yet have any HiOS devices, try saving the configuration from one of your classic switches and converting it using the online tool. This will help you to estimate the effort required for a network upgrade. Then, when the time comes to actually migrate your network, you can tackle the task with confidence.